problem is sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. We need to prove it is equal to tan theta. Definitely in this problem we have to take left hand side and prove the right hand side, children. So let us take the left hand side, LHS, that is sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. So that is equal to, so if you observe very carefully, children, you can observe here sin theta is there, here sin cube theta is there. I think you should be knowing that you should take common. You should take common. What is common here? That is sin theta. Sin theta is common because here sin cube is there. So we should take sin theta, which is having the lowest power. That should be taken as a common here. So if I take sin theta as common, here it will be left as 1 minus 2 sin square theta. Because already 1 sin theta has come outside, definitely in the sin cube theta it becomes what? Sin square theta. Because sin theta is outside here. Again in denominator the same way, we can see cos theta is there, cos cube theta is there. So here we need to take cos theta as common. So it becomes 2 cos cube cos square theta. Not cos cube here, it is cos square because 1 cos theta we have taken already outside. So this cos cube will become cos square theta minus again 1 because already the cos theta has been taken outside here. So you can observe that sin theta by cos theta. Sin theta by cos theta, children, you should know that it is nothing but tan theta. So it is tan theta. So tan theta we already got, but here you can see both 1 minus 2 sin square theta is there, here divided by 2 cos square theta minus 1 is there. So these two terms should not be there here. So already we got RHS tan theta, but these two terms, how to cancel these two terms? Either we need to write sin square theta as 1 minus cos square theta, or if you write this as 1 minus cos square theta, then you write this denominator as it is. No need to change the denominator. Or if you want to keep numerator as it is and change the denominator as 1 minus sin square theta. So any one you should do, children, here. So let us take this sin square theta as 1 minus cos square theta. So we will write 1 minus 2, in the place of sin square theta we can write this as 1 minus cos square theta divided by 2 cos square theta minus 1. So what I did here, this is sin theta by cos theta is nothing but tan theta written. In the place of sin square theta I written as 1 minus cos square theta. Please be very careful with the brackets here. We have put a bracket here because 2 is outside here. You have to be very clear. And denominator, please don't do anything. You keep it as it is because we are trying to make both numerator and denominator in terms of cos. So we'll continue with this. Next step is tan theta as it is into. Now in the numerator we have to open the bracket here. That is 1 we'll write as it is. 1 minus, because minus is there already, 2 into 1. It is minus 2. So minus into minus. So you have to be very careful, children, with this, plus 2 cos square theta. 2 cos square theta divided by 2 cos square theta minus 1. 2 cos square theta minus 1. We have written the denominator as it is. We have not changed the denominator, we have written as it is. So that is equal to tan theta into 2 cos square theta. We will write first this 2 cos square theta as it, we have written here. 1 minus 2. 1 minus 2 is minus 1. Please be very careful about this. 1 minus 2. 1 minus 2 is minus 1. Divided by 2 cos square theta minus 1. You can see so clearly both are same. So that's the reason we can easily cancel this. And we get the RHS is tan theta. That is equal to RHS, right hand side. So therefore LHS equal to RHS. So this is how we need to prove this sum here. See, you have to observe very carefully is by first step is taking sin theta as common, then cos theta in the denominator, sin theta by cos theta is tan theta. Then we have to be very careful in solving these because we need to cancel these two terms. These 1 minus 2 sin square theta and 2 cos square theta minus 1. We don't want these two terms. So how to do that? We have changed sin square theta as 1 minus cos square theta. And then we have simplified and we got this tan theta. That's how we got LHS equal to RHS. So let us go for the next problem. That is cos A by 1 minus sin A, that is equal to secant A plus tan A. So in this problem also, either we can take the RHS and prove the LHS, or we can take LHS and prove the RHS. So you can do either way. I will take RHS and prove the LHS now. RHS, right hand side. Both the ways you can prove, children. It's not necessary that you should take LHS and then prove RHS. I have taken RHS and proving the LHS now. Secant A plus tan A. See, you have to be very clear with the concepts. That is nothing but secant A is 1 by cos A. Tan A is sin A by cos A. So this is how you need to be very clear with the tan A means sin A by cos A. Secant A means 1 by cos A. So again the same thing, the denominators are same. So write cos A as it is. In the numerator 1 plus sin A. Because we'll write the same thing. Why the same thing means because denominators are same. So we'll write numerator as it is 1 plus sin A. So you can see very clearly, children, it is here we are getting 1 minus sin A, here it is 1 plus sin A by cos A. It's a very important to observe on left hand side because we are taking RHS. A very important step is we need to rationalize the numerator. Every time we used to do rationalize the denominator, now we are going to rationalize the numerator. 1 plus sin A is there, we will multiply by 1 minus sin A by 1 minus sin A. That is multiplying both numerator and denominator by 1 minus sin A by 1 minus sin A. You can observe very carefully this step 1 plus sin A into 1 minus sin A. So this is again A plus B into A minus B. It is A square minus B square. That is nothing but 1 square minus sin square A divided by the denominators are cos A into 1 minus sin A. Of course, 1 square is nothing but 1 itself. Children, you should know that very well. 1 square is 1. So 1 minus sin square A. Again the identity. 1 minus sin square A is cos square A. Cos square A divided by cos A into 1 minus sin A. And you can observe very carefully that cos square A is there, here cos A is there. So we can easily cancel cos A and 1 cos A will get cancelled. So what are you going to get? Cos A by 1 minus sin A. You can see very clearly that is nothing but left hand side. We have got left hand side, LHS. So therefore we have proved that RHS equal to LHS. So RHS right hand side is equal to LHS. So this is also a problem, but only the thing is that we need to observe is 1 plus sin A is there. We have rationalized the numerator part. That is plus sign means minus. If it's minus sign was there, it should be plus. That is called as rationalizing the numerator, and then using the identity 1 minus sin square is cos square A, and then we have simplified and we got the left hand side choice. So the next problem is we need to prove that sin A into tan A by 1 minus cos A equal to 1 plus secant A. So in this problem you can observe, children, it is RHS is coming 1 plus secant A, and we have to be very clear about this. Is sin A into tan A is there. So this tan A should be written as sin A by cos A. That is very important because we don't want tan A at all here. We wanted secant A here. So what we'll write here means sin A into sin A by cos A. Sin A by cos A is nothing but tan A. And of course this will be written as it is 1 minus cos A. That will not change, children here. So that is actually the left hand side. I have written directly, I have taken here. The left hand side I have taken and I have start doing here. So sin A I written sin A as it is. In the place of tan A I written as sin A by cos A, and 1 minus cos A I written as it is. So here children, you need to observe very carefully is that sin A into sin A is nothing but sin square A divided by 1 minus cos A into this is very important to understand. Sin A into sin A, sin square. 1 minus cos A into cos A. Into cos A. It is as it is, we are just multiplying here as it is here. So, here we need to observe very carefully what we should do further step. So, sin square A. Here sin square A can be written as 1 minus cos square A. That is 1 minus cos square A. Why we are writing this sin square as 1 minus cos square means because here 1 minus cos A. This is actually telling you people that sin square A we should write as 1 minus cos square. Always whenever we do the sums, children, we should be observing and thinking about what we should do the next step. Actually, we should always have the idea of thinking further step. What will happen if I take like this? That is always you should have in your mind. So, divided by 1 minus cos A into cos A. So you can observe all of your children, it is 1 minus cos square A is. So here 1 minus cos is. I can use A square minus B square formula. Again, the formula which you people have learned, identity. Because 1 plus cos A into 1 minus cos A. This is an identity we are using, that is A square minus B square formula. A plus B into A minus B. Divided by 1 minus cos A divided by into cos A. You can see, children, it is very simple to understand why we have written 1 minus cos square A for sin square as 1 minus cos square A, because in our mind you should have that we can easily cancel this 1 minus cos A and 1 minus cos A, children. That is the reason we have written this sin square as 1 minus cos square A. And then we are using A square minus B square. It is 1. 1 square is 1 itself. It is A plus B into A minus B. That's how we got cancel this 1 minus cos and 1 minus cos. So what we are getting here? 1 plus cos A by cos A. But still, we have not come to the right hand side still, children. So it is 1 plus secant A, sir. So what we should do for this is very important for you. You need to observe this. Cos A is actually a common denominator. It's a common denominator, we say. Common denominator means it's for both also, this is the same denominator it is. So we can split like this. 1 by cos A plus cos A by cos A. This is actually a common denominator here. 1 by cos A will write it plus cos A by cos A. Cos A by cos A. And this cos A will get cancelled here. 1 by cos A. 1 by cos A is nothing but secant A plus 1. So secant. So 1 plus secant A or secant A plus 1 both are same, children. It's not different. So we can write this as 1 plus secant A. That is nothing but RHS. It is LHS equal to RHS. So that's how we have proved that LHS is equal to RHS. So this is how we need to solve. This is one of the important sum for the part of your examination, for the 10th standard examination, 10th standard ICSE examination. It's very important. Even for CBSE also, this is a very important problem it is. And this carries about 3 marks problem. Definitely these type of sums, you need to concentrate, children. So you need to work on this type of sums. So let us go for the next problem here. That is 1 minus cos square A by 1 plus sin A equal to sin A. So definitely, children, we need to take the left hand side and prove the right hand side here. So here, what is that left hand side here? LHS is 1 minus cos square A divided by 1 plus sin A. What we can think about this? Cos square. Always the cos square A comes means, children, we should have that identity in your mind. What is that? 1 minus sin square A, because 1 minus sin square is cos square A divided by 1 plus sin A. So cos square A I have written as 1 minus sin square A it is. So that is equal to 1 minus. So here also you can observe all of you children. So it is A square minus B square. Why we should use, children? That's very important, because 1 plus sin A is there here. If you are going to apply a square minus b square, you can apply a plus b into a minus b. So that 1 plus sin a, 1 plus sin a will be get cancelled. That is an idea you should have in your mind. Whenever we are doing a sum, I said, you should think 2-3 steps ahead of that. Mind should run in that way. 2-3 steps, what will happen? Then only you should start doing this sum. You can't just think only this step and stop it and think further, not like that. This step will happen, the next step what will happen in your mind, you should run in that way. So 1 minus sin square you written, so a square minus b square, that is a plus b, that is 1 plus sin a minus b, that is 1 minus sin a divided by 1 plus sin a in the denominator as it is. So 1 plus sin a, 1 plus sin a will get cancelled. So what are you going to get here, children? You will get 1, you will write 1 as it is, minus is there, you have to write minus into plus, minus 1. Children, you have to be very careful with the sign. The sign mistakes I observe many will go wrong in this, especially sign mistakes. Everyone will do up to here, the sign mistakes will be wrong here. So minus 1, minus into plus, minus. Minus into minus is plus sin a. You can observe very clearly, that is plus 1 and minus 1 get cancelled. So that is nothing but your RHS sin a. That is equal to RHS, that is LHS left hand side is equal to right hand side, children. This is how you need to prove this. So this is also one of the very important sum where you need to think about that, how to go on. That is first thing you have to learn is how to go on with the sums. So cos square a is coming, what I should do? I should write 1 minus sin square a. Then if I get 1 minus sin square a, I should use a square minus b square. It is a plus b into a minus b. Then I will get cancel this 1 plus sin a. Then I will be able to do this. So this is also very important for the point of your examination. So be very clear, children, about this problem.
3.
So this is one of the very important problem for the point of ICSE 10th examination. It has come in 2000 and 2013. It's one of the very important sum. It has come 2 years, and it is the most expected question for the board examination. So this is square root of 1 minus cos a by 1 plus cos a. You need to prove it as equal to sin a by 1 plus cos a. Students, we have to take the left hand side because here this root is sinusoidal. Root sinusoidal means definitely we have to consider the left hand side, and then we can come back to the RHS. So let us take left hand side, LHS, the square root of 1 minus cos a by 1 plus cos a. So this is actually left hand side. You know very well, whenever we get this 1 minus cos a by 1 plus cos a, immediately we start thinking that we should rationalize. But when you rationalize, you have to observe very carefully. Here in the denominator is 1 plus cos a is there. So this 1 plus cos a has to remain as it is. So children, we have to be very careful. We have to rationalize the numerator. Every time what we do means we rationalize the denominator. But seeing this RHS, it is denominator is 1 plus cos. This 1 plus cos a has to remain as it is. So if it has to remain as it is, we should rationalize the numerator. So rationalize the numerator means it is 1 plus cos a by 1 plus cos a. We have to multiply both numerator and denominator by 1 plus cos a by 1 plus cos a. So seeing this RHS, see, that is what I am trying to say. For every problem you have to be very clear with observing both left hand side and right hand side. So after this you can do as usual we were doing the previous sum. 1 minus cos a into 1 plus cos a. It is again a minus b into a plus b. It is a square minus b square. That is 1 square minus cos square a. That is 1 square a. That is, this is 1 square only it is. A square minus cos square a minus b into a plus b. And here it is 1 plus cos a into 1 plus cos a. It is a plus b into a plus b. It is 1 plus cos a whole square. It's a very important step here, you need to understand. 1 plus cos a into 1 plus cos a is 1 plus cos a whole square it is. So that is equal to square root of. So you should understand 1 minus cos square a is nothing but sin square a. Sin square a. That is an identity. Again we are using that identity. 1 plus cos a whole square, we write as it is. Now children, you will have this problem with this square root. So we need to remove this square root now. Then only we will be able to get what we call it as RHS. So what we can write this, we can also write this as sin A divided by 1 plus cos A whole square. Is it not same? Sin square A by 1 plus cos A whole square as sin A by 1 plus cos A whole square. So we can easily cancel square root and square, because a square root is nothing but half. A square root is nothing but half. Half into 2, both will get cancelled. That's the reason we are cancelling these two. So when we cancel, we will get the RHS, that is sin A divided by 1 plus cos A. So that is nothing but RHS. So we have proved RHS is sin A by 1 plus cos A. That's nothing but LHS equal to RHS. So we have proved it. So children, you need to observe the problem. That's what. Here it is plus 1 plus cos A, root of 1 minus cos A by 1 plus cos A is there. We need to rationalize the numerator. That's the first step. You need to be very careful while solving this sum. So now let us go for the next problem. That is 1 by sin A plus cos A plus 1 by sin A minus cos A. That is equal to 2 sin A by 1 minus 2 cos square A. So when you observe this problem, children, you need to observe is that we should take the left hand side and do the right hand side. So LHS, that is 1 by sin A plus cos A plus 1 by sin A minus cos A. So you can observe, I already explained you that whenever plus or minus sign comes, you should take LCM. So the LCM is sin A plus cos A into sin A minus cos A. This is the LCM we should take. You should know this very well. Sin A minus cos A into 1 is sin A minus cos A, plus again sin A plus cos A into 1 is sin A plus cos A. So children, we have taken only the LCM concept here. So what happens here? Minus cos A plus cos A will get cancelled. That you should be very clear. Sin A plus sin A, you know very well, it is nothing but 2 sin A divided by, again, A plus B into A minus B. Again, A square minus B square. That is sin square A minus cos square A. I think you should be fast enough now to do this, because we are doing so many times. Sin A plus cos A is A plus B into A minus B. It is A square minus B square. So we have got 2 sin A. We already got numerator, the RHS. Denominator, it is 1 minus 2 cos square A, and here it is sin square A minus cos square A. That means we don't require sin square A. Instead of that, what we can write here? We can write sin square as 1 minus cos square A, and this minus cos square A we will write as it is. The minus cos square A will be written as it is. Sin square A means 1 minus cos square A. So that is equal to 2 sin A divided by 1 minus cos square A minus cos square A. Children, you should know that it's addition. So it is 1 minus 2 cos square A. So that is nothing but RHS. That is 2 sin A by 1 minus 2 cos square A. We have proved it. That is equal to RHS. So we have proved that LHS equal to RHS. So this also a very important sum. It has come in 2002. In the 2002 examination, this problem has come. It's one of the very important sum. Children, you should be very careful, and you have to think and solve this sum. So the next problem is cot A plus cosecant A minus 1 by cot A minus cosecant A plus 1 is equal to, we need to prove it as 1 plus cos A by sin A. Children, this is one of the very important problem. Here most of the time many children have in their mind cot A should be written as cos A by sin A, cosecant as 1 by sin A. That is got used of it. So this is one of the special problem. So we have to be very clear. In the place of 1, in the only numerator I'm trying to say, in the place of 1, we should write 1 is equal to cosecant square A minus cot square A. Only in the numerator, not in denominator. The 1 is equal to cosecant square A minus cot square. This is a special problem, as I said to people. So let us take the left hand side first. That is cot A plus cosecant A minus 1 divided by cot A minus cosecant A plus 1, that is equal to. So you please observe very carefully this 1. The 1 should be written as cosecant square A minus cot square A. As I said to you just now, we have to write as it is this one, cot A plus cosecant A. As it is, we should write minus, this 1 should be written as cosecant square A minus cot square A divided by, the denominator has to be written as it is, no changes in the denominator, that is cot A minus cosecant A plus 1. So this is one of the special problem, as I said to people. See, you need to substitute in the place of 1 as cosecant square A minus cot square A. That's the identity which you people are knowing very well. So the next step is that we need to think further is, when you observe this cosecant square A minus cot square A, it is nothing but A square minus B square. That's a formula, you have to be clear with this. That is nothing but, that's equal to cot A plus cosecant A minus, as I said to you, this is A square minus B square formula. What you should write A square minus B square as A plus B into A minus B. That is cosecant A plus cot A cosecant A minus cot A. So this is one of the very important steps, children, you need to follow. That is A square minus B square is A plus B into A minus B. And denominator should be written as it is. There should be no changes in this. Cot A minus cosecant A plus 1. The denominator has to be written as it is. No changes in this. You will come to know why we are trying to keep the denominator as it is here. So this you can write it in a bracket, just because you people need to understand. Cot A plus cosecant A is there, cot A plus cosecant A is there. That's very clearly says that you should take common these two terms. You can just see that I put a tick here. These are common, you should take it. So when you take common, the next step is that you are going to take a common here. That is cot A plus cosecant A. Cot A plus cosecant A is a common I have taken here. So what is left here? If I take cot A plus cosecant A, what will be left, children? It is going to be just 1. If nothing is there, we should take it as 1, not 0. Some of the children have that in their mind. If I take the cot A plus cosecant A, they think it is 0. It is not 0, it is 1. Because it will be into 1. So it will be 1 will be written. Minus, be very careful with this, minus is there. And cot A plus cosecant A we have already taken as common. So this minus will carry with this term. So minus cosecant A. 1 minus cosecant A. Be very clear about this, children. It is minus cosecant A, and minus into minus is going to be a plus cot A. A very important step, children. So you need to be very clear. It is minus cosecant A, minus into minus is plus cot A. This term is already we have taken as common. It has been taken as common here. Divided by, the denominator will be left as it is. That is cot A minus cosecant A plus 1. This term will be left as it is, no change. Because the reason is very clear. Here you can see 1 is there, 1 is there. Minus cosecant A is there, minus cosecant A is there. Plus cot A is there. So the reason is that we can easily cancel these two terms. For that reason we have kept like this. So that is equal to. So now what are you going to get here? Cot A plus cosecant A. So cot A plus cosecant A, we got the terms. So we have to convert this in terms of sine and cos. Why should we convert this? Because the RHS is in terms of sine and cos. Automatically, you need to understand that. So cot A can be written as cos A by sine A plus cosecant A as 1 by sine A. So this is what you need to be very clear about it. So sine A is actually the LCM and cos A plus 1, or you can write this as cos A plus 1, because the denominators are same, just add the numerators. So this is nothing but 1 plus cos A by sine A. Cos A plus 1 or 1 plus cos A, both are same. That's equal to RHS. So we have proved that LHS equal to RHS. So this is one of the very important sum, because it has got that, you have to think about the sum, how it keeps on going on. I hope you people are following the steps, because once if you follow the step, this is 1 can be written as cosecant square A minus cot square A. Then we have to write this A square minus B square as A plus B into A minus B. Very important. You can do the cos A by sin A, that I said, cosecant as 1 by sin A, you can do it. But what happens, that will become very lengthy and very complicated. To make it simple, we have used this special substitution. That is 1 as cosecant square A minus cot square. When I use this special substitution, I can go on with the sum with more simple way, as well as the problem can be reduced with the simple steps. So that is the reason I have solved like this, children. I hope it's clear to all of you.